right if I start early?
Sure.
All right. So this is a forum that we're gonna talk about 3D printing, aka additive manufacturing. My name's Rob Conklin. I am a mechanical engineer working in the DoD support industry here in Huntsville. Imagine that. And at my workplace, we live on additive manufacturing. Where I work, we actually have about 30 FDM printers. We have 14 SLS printers, and we have a couple of SLA printers. And we not only prototype with them, but we manufacture with them. We actually create stuff, print those things, and they go out into the field and go into our soldiers' hands. So the technology of additive manufacturing has matured hugely over the past 15, 20 years. And it's exponentially maturing every year. It's just amazing. So a little bit more housekeeping. Gigaparts has been extremely generous here, and I've got some really cool door prizes here. We're going to give away some filament, and we're going to give away a Bamboo Lab A1. Right, mini. It's an A1 mini. Yeah, that's a big deal, right? That's an awesome printer. I actually own an X1C. I grew up on some Cruces and some Crealities. They can't hold a candle to the Bamboo products as far as I'm concerned anyway. They just work. And where I work, we actually have a couple of H2Ds. Let me tell you what, those things they are something else. At the end of this forum, y'all are invited to come up here. I brought some show and tell of my own stuff that I've printed and designed, also some swag from work, and I'll give a little bit of that away. We like to print dice and stuff on the SLS printers. And a couple of things I printed on the H2D too. And
Are those just brand names you're talking?
Bamboo.
No, I know that part, the other ones you mentioned.
They are printers manufactured by Bamboo.
Oh, okay.
They make an X1C. They make
Sorry.
They make a bunch of printers. Every single last one of them is awesome. They really are. And by the way, there's a store here that can give you instant gratification if you should desire to buy one. Gigaparts here in town. And the new store is awesome. If you guys haven't visited, it's really cool. All right, so I was actually asked to do this forum just a couple of days ago. I didn't have much time to prepare, but a good friend and colleague of mine, Kevin Hibbs, actually made this slide deck some time ago, so I'm borrowing it. I very frantically went through it about 40 minutes ago, and added a few things, but I think it'll suffice. Before I go into this deck, how many of y'all own a printer? Okay, about 50-50 mix here. How many of y'all are from Huntsville? Okay, most of you are out of town. That's awesome. All right, fantastic.
Now ask how many have opened the box in 10 years.
Say again?
He bought one, he hasn't opened the box.
Oh, you haven't opened the box
I
yet?
bought it in 2021 at this day.
What is it?
You know what? I forgot.
Oh my.
I bought it and put it in the corner while I finished remodeling the
Well, maybe
Hamfest.
this will inspire you to buy another box that you'll never open. Okay, so I'm going to talk a little bit about what is 3D printing. By the way, guys, I'm going to go like the wind here. Stop me if you got questions, please. What 3D printing isn't, how it works, the different types of printing. There are a bunch of different types of material, the software that you use to do the design of the parts that you want to 3D print, and the software that you use to actually run the printer with. And we're going to talk a little bit about ham radio applications for 3D printing. And I've got some good stuff there on that, I think. I'll talk a little bit about what I've printed and other applications, where the tech's going, similar techs, and we'll talk a little bit about printer costs. I think the numbers in Kevin's slide deck are a little old, but they're still fairly accurate. All right, what is 3D printing? It's commonly known in the industry as additive manufacturing. That's actually what I call it. I'm so used to it because there's so many different kinds of additive manufacturing. By the way, a little bit of trivia. Additive manufacturing's been around for millennia. Casting, that's additive manufacturing. Different types of additive have been around a long time. Plastic injection molding, that's additive manufacturing. Traditional manufacturing would be milling, turning, cutting away, whittling away. But with the majority of 3D printing, especially that people like us do at home, we use a technology called FDM, or Fused Deposition Modeling. I like to call it a CNC controlled hot melt glue gun. Because that's essentially what it is, right? You've got a hot end extruder and you're pushing a filament of plastic through that extruder where it gets melted. That extruder moves around and it deposits a layer of plastic in the shape of what you're trying to print in one thin layer. So if I have an object that I want to print, the slicer tool, and I'm jumping ahead a little bit, but we'll cover this again. The slicer tool will slice this model up in a bunch of slices, and when the printer prints it one slice at a time. That's how it works. In theory, it's really pretty simple. The material choices, especially now, are really, really broad. And we'll talk about materials more later, but predominantly it's polymers, right? Plastics, all different kinds of plastics. Nylons, PETGs, PLAs, polycarbonates, it just goes on and on and on. Typically parts are designed using a CAD tool. Y'all know what CAD is, computer assisted design. There are a lot of tools out there available for the average user to use for free. There's TinkerCAD, there's Fusion 360. There's some other tools that are subscription based like Onshape. My personal favorite is SolidWorks because I actually use SolidWorks to feed my family. And you can actually get a maker version of SolidWorks. I think right now it's $40 or $60 a year, I forget. But SolidWorks is the #1 CAD tool in the design industry globally for a good reason. It's got the best user interface out of all of them. It's just easy to use. Now, easy's relative. CAD takes practice. It is a learning curve for sure. But in my opinion, SolidWorks is the easiest of them all. But they're all very capable tools. Sticking on this slide a bit, great thing about 3D printing is the instant gratification, right? I can download a file, I can design a file, I can send it to the printer, and I can be holding that part within minutes, hours, or maybe a day or two, depending on the size and complexity of the model. That wasn't possible 20 years ago. It wasn't at all. And it was very expensive to have parts made. And now I can have my part and do fit checks, function checks, have something to hold in my hand and see how it feels immediately. And with modern printers, pretty good parts. So 3D printing is not a panacea. It can't do everything. It can do a lot, and it can do more and more every year as the technology improves. I think one of the biggest limitations to all types of additive manufacturing is tolerance, geometrical tolerance, right? Machining and turning, you can hold tolerances of 2/3 thousandths of an inch all day long, easy. The machines are made to do that. Much, much tighter if you want to go through the trouble to hold them to those tighter tolerances. With most consumer grade printers, 5-6 thousandths, that's about as good as you're going to get. If your printer's in a controlled environment or you have a higher end printer that has a full enclosure around it to keep breezes off of it. And the temperatures around it are stable, and the materials that you're running through it are dry and clean and fresh. They will actually hold tolerances to about 2 to 3,000 or 100,000ths of a millimeter. They will do it. When Kevin made this deck, it was probably a few years ago where this was more accurate, but it's getting to where they actually do pretty good. So we talked about this a little bit earlier. So how does a printer work? So you have a CAD file, and most slicers, just about all of them I think, they want to have a 3DF file, an STL file, and some of them a step file. Those are all different types of CAD file formats. There are a few dozen different CAD file formats, but most 3D printing slicer tools, those are the 3 file formats that they use. So you take your CAD file, put it into the slicer, and I'll actually demonstrate this at the end of the forum. I've got the bamboo slicer loaded on this computer. I'll kind of walk you through it quickly. But you load it up in there, you set your parameters. How thick do I want the layers? How wide do I want the stripes that are building the layers to be? Do y'all know what the term infill means? Those of you that have printers do.
Some of them in here are rookies.
Okay, so with FDM printers, the ones that the vast majority of consumers own, they don't print the model solid, right? They will print the exterior of the model solid, and you can set how thick that shell is. The inside of it, though, it prints a choosable infill pattern. It could be honeycomb, it could be just linear box patterns, but the inside is, think of it as a hollow matrix, right? A webbing of plastic structure in there so that it's not solid. And you can set that infill density, right? I can say to the slicer, hey, I want it to be 10% infill. Or I can say 100%, or anywhere in between. Typically people will print at about 15 to 20% infill. Any more than that, you kind of get diminishing returns of strength. Sometimes by adding too much infill, depending on the geometry of the part and how it's being used, you can actually induce brittleness, but I'm getting off into the engineering part of it. So the CAD file goes into the slicer. The slicer is the tool that slices up the model, prepares it with the parameters that you've set for infill, for layer thickness. There's many other choosable parameters. And there are learning curves, guys, to using a slicer, but there is so much high quality data out on the interwebs on how to do this for any given slicer tool that you're using. YouTube is your friend when it comes to this stuff. The manufacturers or the developers of the software, they usually have fantastic tutorials as well. So even if you've never ever done this before, I strongly encourage you to not be scared of it. It's actually surprisingly easy. It really truly is. Anyway, the slicer takes the file, slices it up, preps it up for the parameters that you set, and it creates the file that the printer can use to actually print the model. So, types of 3D printers. All right, the vast majority of printers that consumers use in the house are FDM printers, fused deposition modeling printers. Like I said, CNC hot melt glue gun is squirting plastic out one layer at a time, right? Resin printers. This method is called SLA, stereolithography printing, and what they're doing there is that they have essentially an LCD screen. It's typically very, very high resolution these days. We're talking 4, 6, 8K resolution, very high resolution. And with the FDM printer, you're extruding plastic in the shape of your model one slice at a time and building up on it. With SLA, what you're doing is that the LCD screen is a mask. So it's a negative of the layer that you're trying to print. And there's a liquid polymer that is cured with UV light, and that mask is put on the LCD screen, and UV light is passed through that mask, and it cures the resin underneath that screen in one layer. And then it does it again and again and again and again, and it builds your part out of that resin. SLA printers, this screwdriver, which y'all can see when after the form you see it, this was printed on a very high-end SLA printer at work. The SLA printers are great, but the two main things about them, and there are plenty of consumer-grade SLA printers. Robbie's got them at Gigaparts. You can buy them all day long on the interwebs, from very low to very high prices. My only distaste of SLA printers is it is a liquid polymer plastic they work with. They smell. You know, they have that solvent, plasticky smell. It's a liquid polymer, so it tends to be sticky when you get it on your hands, and you have to clean your hands with isopropyl alcohol or some other solvent. And I found that my significant other does not appreciate any of those things in the house. I don't have one of those, but they are cool printers. Another one that I don't think is mentioned on this slide is called SLS, or Selective Laser Sintering. And what they're doing there is you have a build plate, and a recoder arm puts a very, very fine, thin layer of very, very fine powder down over the build platform. And a laser paints and sinters one slice of your part or parts. And then the build plate goes down, a fresh coating of powder is put on top of that, the laser sinters another layer, rinse and repeat until you have your part. I've actually got a number of SLS printed parts here. All these different methodologies have their advantages, their disadvantages. It could be fiscal, it could be efficiency, it could be polymer choices, it could be dimensional tolerance, but I won't get into that right now. Types of materials. Man, when 3D printing first became a little bit popular, you know, I guess this would have been in the 90s, right? The mid 90s, when people like us could just buy a small little FDM printer. Your only choice was either really ABS or PLA, and the formulations of those plastics were pretty immature, and they had a lot of limitations. They were not strong, they were not heat tolerant, they were not tolerant of UV light. It was cool, but the parts that you could print with those materials had very limited applications, mainly just figurines, light toys, a little bit of utility stuff, but you had to be very careful how you use that part or how much you depended on it, especially because they weren't high quality materials. It is very, very different now. Even the old standby PLA, the PLA you buy now isn't PLA you bought 15 years ago. I used to look down on PLA when I started thinking I was the shizzle bizzle in 3D printing at the house. But now I use PLA a lot because modern PLAs are fantastic. They're inexpensive, they're strong, they print just beautifully, and they even have much higher temperature tolerances than they used to. But most common, PLA is still the most common. PETG is definitely second most common. It is just about as inexpensive as PLA. It is a little bit tougher to print, especially with older printers. They can have a propensity to be stringy, but modern printers don't have that problem. But if you have an older printer or a very low-end printer, you're probably going to end up tweaking your slicer settings doing a lot of YouTube studies to figure out how to tweak those slicer settings to get a good print out of PETG. Modern printers, not an issue at all. ABS. ABS is a very old polymer. It's been around a long time. It's strong. It's fairly UV resistant. It's very temperature stable. The only caveat with ABS is kind of like the SLA resins for me. When you print in ABS, it outgasses and it smells. It smells like hot plastic, and it's a fairly strong smell. It also does a vapor deposition on the inside of your printer. If you have a fully enclosed printer, if you print ABS just 5-6 times, you'll notice the inside windows of your printer are foggy. ABS, it'll vapor deposit a film on stuff, and I think about, golly, I'm breathing that, so I don't use it except in the garage. TPU is a popular one. TPU is a material. Yeah.
Maybe do you still have to hot acetone vapor the finished product?
You don't have to do that. You don't have to do that with any polymer, but many printed polymers, what he's talking about is vapor smoothing. So with FDM printing, you're printing in layers. Right? So when you have the part, the layer lines are typically very visible. You can see those layer lines. Vapor smoothing is where you use a very strong solvent. It's usually either MEK, methyl ethyl ketone, or acetone. And the part is put in a little enclosure, and it's exposed to very high concentrations of one of those solvents, vapors. And essentially, it melts the outside of the part. It smooths it. You don't have to do that. It's mainly an aesthetic thing, just to make those layer lines go away.
I was under the impression that it also melded each layer together more firmly.
It only does it on the exterior, and it's actually been kind of shown too that sometimes it can cause embrittlement. And if you don't get that, and sometimes the solvent vapors will continue traveling inside. There's a lot of controversy over vapor smoothing. Industry does it. You can still buy vapor smoothers. I don't own one, and I never will because I hate the smell of those solvents. But as far as whether it adds strength, I think that's dubious. It's primarily there for cosmetic, aesthetic purposes.
Can you mix materials in one project?
Great question. So you can. So in older printers, single filament printers that weren't designed for running multi-material, it's difficult, it's doable, but it takes a lot of custom G-coding in the slicer to stop the printer so that you can load in a new filament, restart the printer, it prints the different material, stops again, rinse and repeat, right? It's doable, but it's difficult, time consuming.
I was thinking of like a 3D circuit board trace within an object.
That technology is beginning to show up in industry. It's very expensive. It does exist, but not at the consumer level. At least not any greater than at the most rudimentary of levels. That said, you can buy conductive filaments, and that can have a very strong bearing in 3D printing for amateur radio, and I'll get to that later. Okay. Yeah, there's nylons, there's different polymers like PLA and PETG that have wood, that have chopped carbon fiber, that have chopped fiberglass. These are things that create a lot of strength in the polymer. Oh my gosh, we could talk about different polymers and composites literally for hours. There's so many out there right now, but these are the most common. All right. Yeah. almost all 3D modeling software can produce files for 3D printing. That is absolutely correct. SolidWorks, AutoCAD, Onshape, Fusion 360, Tinkercad, Bamboo Studio. Bamboo Studio technically isn't a CAD tool, it's a slicer tool. But any CAD tool will export files that are designed in them out as STLs, 3DF, or step files that you can put into a slicer to print. Slicers, virtually every 3D printer manufacturer has its own slicer. More often than not, it's a relicensed version of a slicer called Cura. Cura is available for free. It will work on virtually all consumer grade printers, not every one of them, but most of them. And it is a fantastic slicer.
All these PC based or?
Yes, all went.
No Mac? Can you use a Mac?
No, I think that I'm not a Mac user, so I can't speak authoritatively on that. But I would be very surprised if most of these slicers, especially Cura, didn't have versions available on Macs and Linux. SolidWorks, I know for sure will not run on Mac. I don't know about some of the other CAD tools. All right, ham radio applications. Golly, this is just a tip of the iceberg here. Enclosures is a big one. Some stuff that I've done. This is a little Messtastic box that I did a while back. I just designed this little box in SolidWorks and printed it. I printed it out of a very hard durometer TPU. Y'all can come and look at it later. Microbitics box right here. So one of the things you touched on about conductive materials, I'm going to touch on that. So a really powerful thing in amateur radio or in any RF application where you're using additive, if you use a polymer with chopped carbon fiber in it, it is RF opaque. So that can either work for you or against you, depending on the application, right? But in the case of this little microbitics, this thing is very subject to noise, right? It, you know, any AC wall warts that are nearby, anything like that, it hears it. So I printed this box out of PETG with chopped carbon fiber, which effectively is shielding, and it works really well. But if you're going to put something like this Messtastic device, there's a little Bluetooth Wi-Fi transmitter in this module. If I printed this enclosure that I put it inside out of a carbon fiber containing material, I wouldn't be able to connect to it. It just completely locked that RF in and everything outside out. So beware of using carbon fiber materials.
And part of it in PLA and part of it with carbon fibers in it.
Well, same principles apply, right? Where the carbon fiber is, RF ain't gonna go through it. Where a non-carbon fiber containing material is, RF will go through it. I've never done that. It's either all one or the other. I do a lot of mixed material printing, but for the characteristics of RF shielding, I typically don't mix. It's either all carbon fiber or all something else. But in my day-to-day work, I actually leverage materials with carbon fiber in them frequently to shield electronics, and it works really well. It's really wonderful though, you know, in the past we always would buy project boxes, right? Go to Radio Shack, buy a little plastic or aluminum project box. Now you order it on Amazon, but same thing, and you'd usually draw up what you wanted, you take it in the garage and you drill holes in it, and that was all great and it was fun, but I imagine you guys, especially y'all that are my age or older, you'll sympathize with every time I did something like that, I was never really that happy with how it looked on the outside. Because I would have to use a label maker or a Sharpie or something, and it just didn't look professional. But now, oh my gosh, you don't have to drill anything, and you can print your labeling into the part, right? Like this guy, I know it's far away, but I've got lettering in here. And as far as holes go, especially for like say a BNC connector, for instance, typically a bulkhead mount connector is a D hole or a double D hole, right, to prevent it from rotating. I can't drill that, but I can print it. So I can actually print the holes in my enclosure lids. They're exactly the geometry that I want, where I want, and I don't have to deburr anything.
You can melt metal threads,
Yes.
inserts into it too.
So this box, I think, this one I used plastic screw holes. Here's one. So this is actually something I did for work, but this little enclosure, you'll see the little brass threaded inserts in there. So you can buy these little brass inserts in all different thread patterns, all different lengths, many different styles. They've been around forever. They're actually predominantly used in the plastic injection molding industry, but they're great for this stuff. So you print a hole for this little threaded heat insert, and typically the way people like us do, you use a soldering iron, and you put the little thing in the hole, and you just melt it in there, and you're done. And now you actually have a metal threaded insert, so you can use a machine screw, and they work really well. If you're actually into antennas, which I think a lot of us are, additive is really great for that because you can print coil forms. You can even put ridges or spirals in your coil form to hold your wire at the spacing that you want it. You can design and print your own spacers and bushings for Yagis or whatever else you want. I think additive has been the best thing since white sliced bread when it comes to antenna home brewing. For me, it's been fantastic.
Yeah, question.
Yeah.
One of the things that I kind of wanted to print, but why I haven't opened the box is because the platform's not big enough for like a 19-inch rack mount plate or something.
So that's a very common problem. People want to print something that's bigger than the build plate of their printer. And that's where you have to think about it creatively on the design side. So parts like that, which I'll do frequently, I'll design the part, but while I'm designing it, I'll keep in my mind that I'm going to have to cut it. I'm going to have to cut it up. So for instance, if I've got lettering or a hole, I'm going to place that lettering or that hole to where I'm not going to cut right through that hole. I will incorporate some geometry in the part ends where they meet together that will help me jig them, right? Think of like simple tongue and groove, dovetail, dowel pin holes, whatever. But I'll print it in multiple parts, and then I'll take those parts and put them together. I can use adhesives, epoxies, CS glues, whatever. I've actually used dowels and stuff like that, and I printed the dowels. That's about the only way you're going to be able to get away with that sort of thing. Very, very commonly done. It's also why we really covet bigger printers.
What's the biggest printer that you use? What's out there that you have?
The biggest printer I've personally used was made by a company called Modix. It was at work, and it had a build volume of 6 feet by 3 feet by 3 feet. It was pretty big. It was an FDM printer. It is fairly large. We, at work, I actually had to go through a big long trade study, and we just bought a really big SLS printer, and it has a build volume that's just massive. And just a little bit of trivia, that build volume if I'm gonna do a full build cake in that SLS printer, it's 55 kilos of powder. And at $299 a kilo, whew, it's expensive.
That's double, you know. Double, it's like a
Oh,
farm.
yeah, just, yeah.
Well, you still could use whatever liquid's left after you.
So SLS is powder, but yes, that's one of the great things about SLS versus FDM. So I'll talk a little bit about that, if y'all indulge me. So with FDM, one of the foibles of FDM is that you can't print molten plastic into a shape in midair. All you're gonna get is a stream of molten plastic. It's not gonna stop in midair for you. So you have to print support off the build plate that will meet an overhang to support it. Otherwise, you won't be able to print the overhang. It'll just drip plastic on the build plate, or it'll sag down and ruin the part. On an FDM part where you have printed support, that printed support contributes to global microplastic, period. I have yet to have found someone that will recycle this stuff myself. It's hard to find. I actually charged one of my engineers about 3 years ago, said, Anastasia, your job for the next 2 weeks, I want you to find a way to recycle this stuff. Because we were accumulating it by the 55-gallon drum every 2 weeks. I mean, just massive amounts of this nylon plastic. And it broke my heart to throw this crap in the dumpster. We failed.
Just goes to landfill.
And no one takes it. Now, SLS, and hopefully that will change, right, your congressman, SLS, the powder around the centered part is the support. The uncentered powder is the support. So that gives you a couple of huge benefits. One, in an FDM printer, if I print a part on the build cake, or on the build plate, I can't print anything above it. You know, that would be printing on top of your part, right? I can't do that. So if I've got a Z height in the printer that's say 12 inches, and I've got a part that's 1 inch high, I can't print anything above it. So all that Z height is unusable. In an SLS printer, you're filling that whole build volume up with powder, and you're only centering the part that you want printed out of that powder. The uncentered powder becomes the support. So I can fill that build cake up with parts, just fill it up with parts. All that uncentered powder gets reclaimed and put back into the printer for use.
So you can potentially print multiple parts in one shot, and like you said.
There's no potential. We fill those printers up with parts. Just fill them up. So if I have a build volume that is that tall and this big square, I will just fill that whole thing up with parts, as many as I can pack in there. So the SLS systems are particularly great for actual manufacturing, because I can make just an amazing number of parts in a very short period of time with very little touch labor. It's really pretty awesome. The main caveat with SLS is it's not for us plebes, it's expensive. There are some people, some companies coming out with low-cost SLS systems, but I think they're still around 15K minimum. The first SLS printers that we got where I work and that are still manufactured actually here in the USA, a company called Formlabs out of Boston. They make great printers. Their Fuse 1 printers right now are around 30. And then you have to get the machine, clean the parts and to reclaim the powder. That's about another 15. Then you have to get a bead blasting cabinet to clean the parts off. That's however much you want. It adds up.
Kind of tangential question. Do you know, does Shapeways still do SLS off the top of your head?
I do not know.